For weeks, the world's biggest telescopes, Gemini South, Hubble, JWST, and others followed the enigmatic interstellar object entering the inner solar system, Comet 3 ATLAS. Then suddenly, the images stopped. NASA went quiet. The data streams froze. Into that silence, China stepped forward. From observatories in Yunnan, Tibet, and Xinjiang, new high-resolution images began appearing. Nobody else could see the green, glowing comet's frames. It was referred to as such in the West. Coincidence. Others spoke softly, censorship. But what these telescopes revealed wasn't just about a comet. It was about who directs the narrative of discovery. When the universe decides to open its window and the sudden change in the air. When the faint speck named C 2025 and 1 became available on July 1, 2025, it was immediately recognized by astronomers for its significance. Its hyperbolic orbit, with eccentricity greater than 1, marked it as an interstellar visitor, only the third confirmed individual after Oumuamua in 2017 and Tuai Borisov in 2019. For weeks, observational data poured in from top facilities like NASA, ESA's Hubble, JWST, and Gemini South. Together, they sketched the initial contours of an alien comet traveling nearly 60 kilometers per second, cutting through our solar system at a speed faster than any planet. At first, the global community of astronomers worked in unison. The Very Large Telescope's 8.2 meters mirror in Chile recorded the comet's magnitude close to 14.5, whereas others captured spectra in the infrared, showing distinctive gas signatures. Then, however, a gap opened. As solar elongation decreased below 30, the comet sank into sunlight, making tracking from Earth's largest telescopes nearly impossible. The imaging windows of Hubble had expired booked. JWST was protecting itself from heat-safe mode. Even the dual 8 meters Gemini mirrors faced downtime. For nearly 10 days, the greatest observatories in the West became dark. China stepped into that void, no surprise. Chinese observatories, led by facilities in Purple Mountain and Xinjiang in the Yunnan region, started distributing high-resolution wide-field imagery of 3I Atlas. Their instruments, some newly upgraded with 4K CCD arrays and automated tracking software, captured the comet precisely during the window when Western systems were blind. Online, each release was available within hours, frequently supported by brightness estimates and trajectory overlays. The narrative suddenly shifted. Where once NASA's feeds defined the story, China's images cleaned up, on time, and filled the silence and filtered. In those frames, the comet's green coma shimmered under sunlight. And for many, the symbolism was clear. A new player had entered the race to decode the universe's rarest visitors. This wasn't just a matter of convenience or timing. The Chinese images revealed detail and continuity that no other observatory could provide, sparking both admiration and anxiety throughout the scientific community. The initial release arrived from the Liang Observatory in southwestern China, a 12-step sequence of exposures, each lasting 180 seconds, stacked together to make a clear time-lapse. It showed the comet's coma expanding to nearly 600,000 kilometers, its tail barely visible against a background filled with stars of magnitude 12. Over the following week, the nearby Jinglong Station in Beijing and the Ali Observatory in Tibet followed, producing wide-field mosaics covering 3 degrees of sky, tracking subtle shifts in brightness as 3I Atlas accelerated toward perihelion. These images did more than just fill in the gaps. They extended the timeline from late August into the beginning of September, when JWST and Hubble were forced offline due to glare and scheduling. The Asian observations were conducted. Their data showed the coma fluctuating in density and form, revealing faint jet structures unseen in previous images. The National Astronomical Observatories of China and AOC confirmed that nearly 0.8 magnitudes of brightness increased in just 3 nights, evidence of renewed outgassing or internal heating. Equipped with high-resolution wide-field CCD systems and adaptable scheduling, fewer bureaucratic constraints imposed on Chinese teams. Automated alert systems flagged the comet's rapid changes, making it possible for telescopes to pivot within minutes. Each frame was UTC precision time-stamped to 0.01 seconds and cross-calibrated against known stars for photometric accuracy. These images weren't just snapshots. They were continuous records during a critical blackout phase for the rest of the world. This meant, for researchers, continuity in light curves and tail morphology, which enables the accurate modeling of outgassing rates and solar wind interactions. But symbolically, it meant more. The data didn't just restore the comet's image. It rebalanced the power dynamic in global astronomy. Yet, as China's telescopes illuminated the sky, Western networks stopped talking. And into that silence, a storm of speculation started to form. As the Chinese images spread across scientific networks and social media, questions surfaced. Where were the Western advancements? NASA was the last to release a public set of Hubble UV images from July 21, 2025 that showed a faint dual tail and an expanding dust coma. After that, however, the pipeline slowed. Usually, raw FITS files are released within 72 hours. These were weeks behind schedule. Some of them, when they finally showed up, had inaccurate calibration data. Online forums filled with amateur astronomers and independent researchers began making allegations of NASA concealing information. Official explanations pointed to quality control, standard protocols, safety of the instruments, and overlap with proprietary observation time. Still, the optics were bad. The timing aligned perfectly with the surge of Chinese output. The general public perceived it as censorship.